Good afternoon and good morning, everybody. My name is Claude Moore. I am a Marketing Development Manager in the Eastern Districts for Intel Corporation. I am the moderator for our presentation today, and the subject of this webinar is Servers Direct and Intel present the latest server products and platforms. In reality, what we're going to present today is the E5-2600 V3, our latest and greatest processor for servers. So you'll get a lot of good information today. Presenting from Intel will be David Borden, and he is our server product technical marketing person. And he'll be doing the bulk of the presentation for about 40 minutes today. And then we've got Todd Swank, Senior Director of Product Marketing Servers for Servers Direct. So we've got a pretty full agenda. We'll also be taking questions throughout the presentation and the webinar. If you can look over to the left, you'll see a dialog box. So just type in your question, and we'll be happy to answer them throughout the presentation. And if we close the audio portion of the webinar and there's still questions up, we'll make sure we answer all of the questions. In addition, we'll be sending out follow-up email with a PDF of the presentation, a recording of it, and also the Q&A in the sessions as well. So let's go ahead and get started, and Todd will also be talking about a NUC drawing at the end of the session, so if you stay throughout the presentation, you'll learn how you can get a shot of winning that product as well. So I'm going to go ahead and turn it over to David. David, I'll let you take it from here, and also we have Jeff Carlson and Kevin Koski answering your questions as well today. Thank you.
Great. Thanks, Claude. Everybody, my name's Dave Borden. I'm an Intel Technical Marketing Engineer, and I work in the data center group, and my main focus is on Xeon E5. Today I'm going to be talking to you about our new product, the Xeon E5-2600 V3. Get started. Let's get through the legalese here. Okay, so Intel's commitment to being a world leader in server technology really shows with the release of the new E5-2600 V3. With that, we hold 27 new world records. One of them, and to me the most important one, is the world's most energy efficient server. This is based on spec power. In addition, we hold several world records in spec int, which is integer performance, spec FP for x86 architecture, which is floating point, spec JBB, and also VMmark. VMmark is a good tell for how well a server works in a virtual environment. So Intel uses a process which we call tick-tock. We will develop a new microarchitecture, let's say Sandy Bridge here, on an existing process technology, 32 nanometer. Now the process technology is actually how we make our wafers, the process at which we create those transistors that our processors run on. Once we perfect that, we will then move on to new process technology. In this case, it's what we also refer to that as a die shrink, and that's Ivy Bridge, which is the E5-2600 V2. This is the processors that you would find in most data centers today. And now that we're on 22 nanometer, we've come out with this new microarchitecture, Haswell, and that's the code name, and the product that you'll see on the shelves is E5-2600 V3, and that's the focus of today's presentation. So what you have here is a graphical representation of the E5-2600 V3 compared to the previous generation E5-2600 V2. Everything you see in blue is new to this new architecture. We have significantly more cores. We have an integrated voltage regulator now. What's important about the integrated voltage regulator is that used to be down on the server motherboard. Since taking that and putting it actually onto the processor die itself, we actually have a much more efficient use of energy. Because it's on the processor die itself, we can actually have a very, very granular control of how the power is used, also from the perspective of monitoring, performance, and in addition to reliability. For power management, we have several new features, one being per core P-state, uncore frequency scaling, and energy efficient turbo. I'm going to talk a little bit about those in just a bit. In addition to these features, we're moving on to DDR4 memory, and there's several advantages to DDR4, and I'm going to actually talk quite a bit about that as well. And the last feature I want to mention, at least on this slide, is Intel AVX 2.0. There's several new features, many of which actually benefit the enterprise now for the first time using new instruction sets. Okay, so this is a real specific, a table that shows the differences between the E5-2600 V2 and the E5-2600 V3. So we're going from 12 cores up to 18. That's a full 50% increase in core count from the previous generation. That's going to offer a very significant difference in performance, especially in those applications that are highly threaded. If your servers in your data centers or in your businesses are virtualized, this is going to make a really big difference. With frequency, I'll talk about that. I have a slide just on frequency alone here in just a minute. We're actually going to be looking at frequency and what our base frequencies are just a little bit different. It's pretty interesting. Again, AVX, I talked about that already, and I have some details in just a bit. With memory types, we're moving from DDR3 to DDR4, and now we'll be supporting RDIMM and LRDIMM. Now, previous generations, we did support UDIMM, but to be honest with you, that was not used very often. And with DDR4, we'll now be focusing on LRDIMM, which in some cases was supported on DDR3, but now there's full support with LRDIMM, which stands for Load Reduced DIMM, and what that allows for is very, very high capacities of memory. And we'll look at some of the performance benchmarks and why LRDIMM is important. Frequency, we're bumping up significantly in frequency for memory up to 2133 megahertz. And that's not the whole story, because DDR4 and the new Haswell architecture, or the E5-2600 V3, allows to have that high frequency when you add more and more memory. And again, I'm going to show you some benchmarks there that shows what that actually benefits you as a customer. QPI speed, that's basically how fast the data gets transferred around the server, bumps up from 8 gigatrans to 9.6. And then TDP, this is an interesting one. You know, I just told you how we now hold the world record for energy efficiency, and I'm showing you the new Haswell processors, or the E5-2600 V3, actually consume more power than previous generations. You may be curious on why that is. Well, the reason for that is that we've integrated, again, I mentioned before, the integrated voltage regulator. Now, because we took the voltage regulator actually off the board and put it into the CPU die itself, that's where that extra power has come from. But really, what counts for you and in your data centers and in your businesses is how much power are you consuming at the plug. And the actual net of that is going to be lower. And especially when the server needs to flex between different types of workloads, that's where it's really going to show up. Also, for power management, we have per core P states, independent uncore frequency scaling, and again, I'll talk a little bit about that in a minute. Okay, so Intel AVX 2.0. I'm sure if you're familiar with Intel technology, even from desktops, we started with SSE, streaming SIMD instructions. With E5-2600, or Sandy Bridge, we introduced AVX 1.0. And what that did is it gave us 2 times the floating point operations of our previous generation. With E5-2600 V2, we introduced half-float support. And what that is it's a 16-bit acceleration. So any instruction code that's 16-bit in nature can benefit from this. In addition to that, probably the most important thing with the E5-2600 V2 is the inclusion of the random number generator. Now, a true random number generator is very important for creating encryption and the hashes that make encryption safe. This random number generator is what makes that happen. And it also does it in an accelerated manner. Now, with Intel AVX 2.0, this is what really makes a difference if you have a data center that, or a business that actually uses enterprise class applications, whether it's databases, email servers, etc., web servers. We have a 256-bit integer vector instruction acceleration, and for the first time ever, we've brought integer acceleration into our Xeon processors. It's always been focused on floating point, and so this is very exciting for us. In addition, AVX 2.0 supports what they call FMA. That stands for fuse, multiply, add. And what that does is it allows the processor to do a multiplication and an addition in one clock cycle, again improving floating point performance. And this is going to be beneficial in professional processor imaging, also in things like you've heard of feature detection, right, where a camera can see a face and actually be able to recognize features for security. So maybe your face will actually be your login here going forward. Basically what that ends up netting out to is up to 70% increase in performance just from AVX 2.0. Okay. I mentioned earlier how we're looking a little bit different at frequency now. So when you were out shopping for a processor or for a server system and you talked to companies like Equus about your integrators about purchasing hardware, they'll say, well, this Xeon processor has a base frequency of 2.3, and you also have turbo that you may get frequencies up to 2.8 gigahertz. Now, because of AVX 2.0 being such a significant portion of our architecture now, and because it creates so much acceleration as far as performance goes, we'll have a regular base frequency, and then we're going to have an AVX base frequency. So if your workloads are AVX specific, then what we'll do is we'll have a published spec for that as well, along with AVX Turbo. Let me move to the next slide. This will make it a little clearer, easier to see. Okay, so I'm just going to build this out here. Okay, so on the left, you can see we have a base frequency of 2.3, and then we have our max all-core frequency that's non-AVX of 2.8. Now, if you have a workload, one of your applications that's been written for AVX or uses AVX acceleration, your AVX base frequency is 1.9, and your AVX max all-core turbo frequency will be 2.6. This is just an example. It's not specific to a certain SKU, but we want you to understand the differences. And the reason we're doing this, right, is we want to make sure that you get all the performance that you can. And so instead of going with the lowest common denominator, which would in this case be 1.9, we're saying, hey, if you're not running an AVX-based workload, then we'll actually run 2.3 full-time. So it's just a different way to look at it, and I'm sure most people will still be looking at the base frequency. But the thing that's important to understand is if you're running very heavily AVX-based workloads, then it will fluctuate between your base frequency and the AVX base frequency. Okay, so what I'm going to show you here is how Intel creates its dies. So normally when Intel would create a processor, we would have a single die. And I'm sure you've seen these wafers in the magazine articles and that kind of stuff, these big round wafers that we cut up, and that's where we get our processor dies out of. They're always generally the same size, and then when we, depending on whatever product that we're selling, they'll do a process what they call fusing. And what the fusing does is it says how many cores we'll use, how much cache it is, and what features are available, and then that's how it determines which part it'll be. Now, with the new E5-2600 V3, we'll actually have 3 specific dies just for this product processor line. When we have a 4 to 8 core processor, we call that low core count, and this is the ring-based architecture that you'll see within the processor. A 10 to 12 core part would be a mid-core count, and we have a slightly different microarchitecture here, and then we have with 14 to 18 core parts a high core count. Now, this is not something that it's important or you're going to be tested on here. What's important to know is I just wanted you to kind of have a little peek into the architecture here. Now, one thing that is different this generation is that for the high core count parts, the actual appearance of the processor will look just a little bit different. It'll actually have these little wings on it. And the heat spreader is that silver surface that you actually put the heat sink on. That's a little different shape as well, and that's to accommodate the higher core count. But don't worry, all these processors, while they look a little different with the high core count parts, all these processors will actually plug into the exact same socket. It'll all be compatible. Okay, so previous generation products, the E5 V2, so we had our E5-1200, which was our entry server. Okay, that's the kind of server you're going to find in small businesses, doctors' offices, lawyers' offices, that kind of stuff. What's great about it is it offers several benefits like ECC, error code correcting, etc. And then when we get into the E5 line, which we're talking about today, that's what we call efficient performance. And that's going to be 95% plus of the server platforms or processors in the world's data centers and in businesses that have a reasonably sized server room. Then we have E7. E7 is our enterprise mission-critical level server for very, very large databases, very large companies. Now, with E5 line, previous generations, we had the 1600, which was our single-socket workstation processor. Then we had the E5-2400, which is the kind of the entry two-socket processor, the E5-2600, which is the standard E5, and then 4600, which was a four-socket E5 class server processor. Moving forward, we'll have the E5-1600V3, which again is a single-socket workstation processor, and then just E5-2600V3, which is the dual-socket processor. The E5-2400V3 will just be for comms and storage appliances. So one of the things you can ask when talking to your the people that you buy your servers from is whether or not their storage or comm products actually has Intel architecture in it, or the E5-2400V3, because it's going to have all the goodness that I'm talking to you about today as far as being high performance and efficient, etc. The good news about this, though, is that we've consolidated the 2400 and the 2600 features into the E5-2600V3, so it'll make it a little simpler to make your server purchases. Okay, so what we have here is this is what we call our SKU stack. And when you're talking about making a server purchase, putting servers in your data centers, these things are important to understand. Now, Intel sells their processors based on different segments, okay? Within the E5 product line, we have our basic processor, okay? It's got 6.4 gigatrans, QPI speed. It supports DDR4 1600, up to 6 cores. And then we'll bump up into standard. But once you get into standard, you get things like turbo boost and hyper-threading. Hyper-threading can allow you to process twice the number of threads than a server with it out or with it disabled. That's very important if you're running in a virtualized environment or you're doing some sort of applications that are highly threaded. In addition to that, you can see we bump up in core count, 8 cores. We have higher last level cache, and our DDR4 speed bumps up about another 20% or so to 1866. Then, of course, when we jump into advanced, you get in a much higher core count, 10 and 12 core, etc. The maximum QPI speed, the maximum DDR4 speed. All these things are important when you're looking for maximum performance out of your system. Now, you may wonder, well, what are all these guys over here? Well, these are segment-optimized SKUs, and what these are for is these are targeted, highly specialized workloads. In this area up here, we have what we call our high core count, or very, high core processors. So we're talking about 18-core, 16-core, 14-core parts. And these, again, are really good in areas such as databases, virtualization, etc. Then we get into the frequency optimized SKUs. These have a lower core count, like 6 or 8 core, but we're in the 3.4, 3.2 gigahertz, okay? You still have really high gigatrans, very high DDR4 speeds, but you also have very high frequency as well. And sometimes these benefit best in areas of engineering, science, and that kind of stuff. It really depends on your application. You can talk to the manufacturer or your software vendor and find out how does your application respond to either core count or frequency, and they should be able to tell you, and that can help you guide your decision in what server or workstation to purchase. Then we look down here in the low power SKUs. Now, if power is really important to you, maybe your server goes a little underutilized every once in a while, maybe during the evening, or it's just that in order to get the density that you need in your data center, you really need a low power SKU. Well, we offer those, and if you take a look here, we still have, even though they're lower frequency, 1.8 gigahertz, et cetera, but you've got 12 cores, okay? So you still have the same number of cores you have up here, but at only 65 watts, so nearly half the watts that we have up here in the advanced, but you're still getting the 9.6 gigatrans, you're still getting the 2133 DDR4 speed, hyper-threading, turbo boost, etc. And you may ask, well, man, maybe they're selling us kind of the lower-end processors here if it's only 1.8 gigahertz. Well, the fact of the matter is, actually, our low-power processors are actually the highest bin processors that we have. They're the best, the highest quality binning that we take when we get them out of our factory, and that's what allows us to run actually 12 cores at 65 watts. I mean, think about that, the amount of power that this processor can do, how much work it can do for only 65 watts of power. I mean, that's barely over the power of a standard light bulb. Move on here. All right. So these numbers here, these are really interesting to me. And this is one of the things that's important to look at if you're trying to decide, well, should I stay on the E5-2600 V2, or should I move on to E5-2600 V3? Now, keep in mind, right, when a new technology comes out, it's going to be a little more expensive. The DDR4 memory is more expensive, but I'm going to talk about all those here in just a minute. The thing to keep in mind, though, the way Intel works, and remember back when I was talking about the tick-tock, right? Well, we create a new process technology about every 18 months or thereabouts. That's actually what they call Moore's Law, and it's allowed us to basically reduce our die sizes, reduce the transistor sizes every 18 months, and then what that allows us to do, and what Intel's historically done, is said, hey, what we're going to do is we're going to come out with this new process technology and then a new microarchitecture, and for the most part, the process or the prices are going to remain consistent through a certain SKU of processor, but the performance difference, basically, in essence, it's free just because the technology marches on. So if we look here at the standard products here for Ivy Bridge, this is E5-2600 V2, this column here, the numbers on the left, these are spec integer. Okay, these are the type of numbers that would represent business class or enterprise class workloads. On the right is spec FP, and these are benchmark results based on the floating point type workload. Okay, and really quick before I go on, I'll talk about what these numbers mean. So the benchmarks I'm showing you, most of them are going to be based on the E5-2600 99 V3. That's our top bin 18-core part. All these numbers here are relative to that part. So our Haswell part here, actually we'll click through one more, I think. There we go. Our E5-2690 has 0.88% of the performance of the E5-2699. So for instance, down here, the E5-2603 V2 is only 20% the performance of our latest, fastest processor. Okay, so that'll give you an idea how that works. But the thing that's most important on this slide here is as you move from your Ivy bridge of the E5-2600 V2, we're talking about the same SKU here, right? 2620 V2 and the 2620 V3. You're going to see up to 23% performance increase in integer performance and 18% in floating performance. If you look at the 2630, whopping 39% increase in performance for integer and 29% increase in floating point, going just from one generation to the next. And again, these two products are probably very similar in price. There may be a few $100 difference in cost. You'll have to talk to your retailer who you purchase your servers from. But it's a very small difference in price, but we basically pass that performance on for free. When you're moving from basic to standard, this is the doozy here. The performance from basic to standard, and that's why I think it's very, very important for me, that makes the most sense when you're purchasing a server, at the very least, starting in standard. And I'll tell you why. Going from basic to standard, you're in the order of 60% more performance just from making this leap from here to here. And again, we're not talking a significant difference in money, but the performance is substantial. If you're moving from standard to advanced, you still get a really big bump in performance. It's approaching 20%, 18, 20%, somewhere in there. But these benchmarks that we have here, these are public numbers, and so these are generalizations, right? But they can give you an idea of what the difference is in performance and kind of where these the sweet spots are for you and where you want to look at purchasing your server hardware.
And those numbers in black, they were the type of processor, correct?
Yeah, right in here?
Yeah, we just got that question. That's why I'm asking.
Oh, yes, yes. So, yeah, so if you see here, E5-2670 V2, that's the SKU. And when you are talking about buying a new server, this is actually the number that they'll use versus E5-2670 V3. The most important thing, yeah, is looking for that V3. Okay. So this here is the some generalization of it's kind of like a general performance summary. The blue line here is the performance results based on the E5-2697 V2. So now, just before last week, this would be the fastest Xeon two-socket processor you would have been able to purchase. Okay. So what we've done is we've run benchmarks, and then all the results you see after this in the light blue color, those are all normalized to the E5-2697 V2 performance, okay? So it's very similar to what I was talking about in the previous slide. This just gives you a reference instead of just showing random numbers. This gives you a reference of how much faster a specific application is, in this case, on the new microarchitecture, the E5-2600 V3. So what we'll see here is we have like spec power, okay? It's the top bin to top bin means that the new microarchitecture, you're going to get about 24% more performance just by going with E5-2600 V3 versus E5-2600 V2. We jump up into here. We have Stream. Stream Triad is a benchmark for memory performance. We're in the area of 44% faster on the new microarchitecture. VMmark, 60% faster. We have Spec Virtualization, which is another virtualization benchmark, 70% faster. Now remember, that's approaching 2x performance in a virtualized workload compared to the fastest processors of the previous generation. LinPack, that's floating point, almost 2x, all the way up to Spec JBB, which is 3x or 300% faster. A lot of that has to do with the core count and also the new AVX 2.0, significant contributors to that performance. Now, the thing that I think you'll find most compelling is when we get to this next slide here. This is a 4-year refresh performance summary. Now, chances are, if you have the E5-2600 V2 in your data center or in your server room right now, chances are very high you're not going to be replacing it right now. We'd love you to do it, but usually companies take about 3 to 5 years to refresh their server hardware. What we have here is a processor, the Westmere processor-based system. Okay, that was introduced in 2011, and this is the fastest Westmere processor we had available at that time, and that's the X5690. Okay, if we are now going to compare that to the E5-2600 V3, so what this means is if you had a system that you installed about 4 years ago, 3.5, 4 years ago, then, and you decided, hey, is it time for us to upgrade now to 2600 V3-based system? These are the type of performance gains you might expect to see. So we got spec power, 3x. That's 300% improvement in performance per watt. That means for the amount of energy you pay for the plug, how much performance you're going to get at it compared to the previous generation hardware. Stream triad, that's another benchmark here, 3x. Spec integer, again, that's integer-based, so that's going to be representative of enterprise-class workloads. See, they're all in the order of over 3x or over 300%, all the way up again to spec JBB of 8.7 or almost 9x performance benefit. So this here, to me, is the most compelling if you're thinking of upgrading your hardware. And you can look at this also at another way. You can replace 3 servers for 1, or you could, for 3 servers that you could put in, you could do 3x the work that you did with your previous generation. It's just a really good value. It's a really good time to replace server hardware. Okay, so if you have data centers or if you have several servers in your server room, chances are pretty strong that it's virtualized. Now, this here is the VMmark benchmarks, okay? And you can see here, this is the E5-2600 V2 top bin processor. Again, these are normalized numbers, so we've taken the top score here, the 2697, and compared it to the 2699 V3. We're 60% performance bump compared to previous generation. But again, when we're talking about refresh cycle, we're over 3 times or over 300% more performance just by upgrading your hardware now in a virtualized environment. Okay, so DDR4. Now, one of the things that you're going to run into as you're shopping for new server hardware, and when you're trying to make your decision on do I go with the new E5-2600 V3 or do I go with the previous generation V2? Now, one of the reasons or considerations why you may consider, hey, maybe I'm going to wait, is because DDR4 is more money. But with any new technology, of course, when it's new, it's going to cost a little more money. But I'm going to explain to you why I think that would be a mistake to not upgrade, and we've got some numbers to show you here. When you end up building out a server, especially if it's a virtualized server with a lot of VMs on it, you can see here, this is the amount of RAM that would be installed in this specific server's case. 128 up to 768 gigabytes of RAM. With DDR3, once you go across 256 gigabytes, you start really losing performance, because as you add DIMMs as you add more DIMMs to a channel, your effective speed of that DIMM, even if you have the fastest processor, if you purchase the fastest processor and then you have to add a bunch of more DIMMs per channel to get to where you need to be, you're going to end up losing performance. So with DDR4, as you add more DIMMs per channel, you can see up here that the 2100 plus megahertz, that stays level. You get everything that you paid for with that high bin processor all the way out almost to the 768 gigabytes. And if you look here, even populating 2 DIMMs per channel, you're talking about 1,500 to 2,000, and that's a good 30-40% increase in throughput for sticking with DDR4. As it says down here, by following this, you can get up to 50% increase in bandwidth. That's with 3 DIMMs per channel. And that also gives you a lot of flexibility when you're purchasing DIMMs. Sometimes very high density DIMMs, meaning DIMMs that are, say, 32, 64 gigabytes in size, they end up being a lot more expensive per gigabyte. And it allows you to have a little more flexibility by buying maybe smaller size DIMMs and populating more channels without taking the hit in performance. For power consumption, you have DDR3 low volt. Now, DDR3 came in 2 flavors. It came in regular, which is about 1.5 volt, and then DDR3 low volt, which ranged from, I think, 1.3 to 1.2 volts, depending on which technology they're on. It's a full 35% less, and DDR4 is actually 1.2 volts right out of the gate. So you don't have to spend extra for low voltage DIMMs, or you don't have to be worried if you're concerned about power consumption, whether or not you can get low voltage DIMMs for that particular platform that you're looking at purchasing. Okay, DDR4 is low voltage right out of the gate. Standby current, this means if the server's not doing a lot, or if the actual server parts within the DIMMs themselves are not being populated at that time, a full 30% less power consumption with standby current. All that adds up to, again, 50% increase in power efficiency.
David, I do have a question from the audience. So
yeah.
A person would say that the whole gain in performance comes from the higher number of cores. Would that be correct or not?
Part of it does for sure, absolutely. All of it, absolutely not. Remember back when I talked about the actual microarchitecture and I talked about shrinking transistors and such? What that allows us to do, and you saw all those SKUs that I showed you, the segment optimized, the high frequency, the high core count, that kind of stuff. By us shrinking the transistors, it gives you the ability to go with either faster frequency, right? You can pick a processor that's higher frequency, lower core count, or higher core count, lower frequency, etc. It allows us to have that flexibility. Sure, there's a good portion of the performance comes from more cores, but when you introduce new technologies like AVX 2.0 and alike, you end up having accelerations available there that you can get over 2x the throughput depending on the workload and depending on whether or not the code has been optimized for it.
Okay, great. Thank you.
You bet. Okay, so let's put some dollars and cents to DDR4 here. So again, when you're making a server purchase, you may get hung up. I know that when I go out to buy something, whatever it is, if I see something's a lot more money than a previous generation, I give pause to it, and I have to decide whether or not it makes sense to actually spend the extra money. And so what we're doing here is we're comparing a total system cost, this is for the hardware and I believe base operating system, being configured the same, okay, between the 2 generation processors. We have, over here on the left, we have an E5 V2 family base server, okay, populating 1 DIMM per channel, 8 gigabyte DIMMs. The total system price here is going to be about just over $11,000. If we look at the same configured system here, we're looking at a price of about $12,300. What that ends up being is about 11% premium of purchasing for the current generation hardware, which, it's real money. You work hard for your money. But when you think about 11%, that's very little. Remember back in the performance slides I was showing you, on average, you're getting between 19 and 25% performance increase, SKU for SKU, compared to the previous generation. So right there, you're ahead of the game. The other thing by purchasing a more current platform is you're future-proofing, right? It's like going to the dealership and buying last year's model car. You can get a price on it, get a decent price on it, but the fact of the matter is when you go to sell it, it's going to end up being a lot cheaper, right, because it's a model year older. In this case, it's performance-based, it's power efficiency-based. especially with things like AVX2. So as more and more code and more applications are written to take advantage of AVX2 and that new integer acceleration, you're going to get real benefit out of that. In addition to the power efficiency, things like per-core P states and other power efficiency advantages that we have in this new architecture, no matter what workload you throw at the system, it's actually going to consume less power per unit of work that it does. So what that comes out to, if you see down here, it's about $1.13 a day, right, over 3 years. Most companies, usually it's on average of 4 years, so of course that price would go down. And if you're familiar with what your IT budget is or what it costs per server when you add in additional software costs, right? Your database software generally is very expensive. You know, all the different suites that you have to purchase to run your business, they're costly. What it costs to actually have people come in and manage your servers, or if you have on-site, what it costs to take care of those servers. This price here obviously goes way up. It's not, your total cost of ownership is much higher than the $12,000. So what I'm getting at here is just when you go to make your purchase decision, you want to look at the total cost of what it is, and then what it amortizes out for, and then what you're actually paying extra. And don't get hung up on, yeah, you're going to pay about 20% or 30% more for DDR4 memory. But the truth of the matter is, when you do the math and you look at it over 3 or 4 years, like any businessman would, that's what you're going to end up, it's going to be a lot less expensive than it first appears when you look the numbers over. Okay. A little more about DDR4 as far as performance. So Stream Triad, which is a memory benchmark, it shows the actual memory throughput. Again, here we're comparing to the top end E5-2600 V2 at 1 DIMM per channel. Okay, that's the minimum that you would populate as far as channels. We have three channels per. Got 4 channels, 3 DIMMs per channel, okay? So 1.16, so 16% at the very minimum performance bump. That's not talking about energy efficiency here, by the way. We go 2 DIMMs per channel, 20%, and then 3 DIMMs per channel. Remember back when I was talking about having the flexibility of buying different density DIMMs to find out what the best value is to get to the amount of memory you need. Because as you start populating more DIMMs per channel, you end up losing some of that performance that you're paying for in the processor. So again, it gives you more flexibility here, 40% increase in performance. Now, when we go back and look at the refresh performance of a system that you might have from 4 years ago, you're looking at approaching the 3x or 300% and over, depending on what the actual configuration is. Again, and one thing you'll notice is a lot of these numbers I'm showing, they're all very consistent, and the reason for that is Intel spends a great amount of time making sure that our systems are balanced. So no matter what kind of workload we hit it, we're going to see similar scaling across all subsystems. Okay. This is just a quick note on Intel processor heat sinks. I know that when you go out and you look at purchasing hardware, you know, I do the same thing. I go to stores and I want to find out what the best value is when I spend my money. This is something I have intimate knowledge of. Right? I work with the guys that actually do the engineering, design, and testing of these thermal solutions. One thing I can tell you, and it's something to very much consider if you buy separate heatsink solutions for whatever platform you're looking at, that you really consider the Intel heatsinks, the heatsinks. The thing about Intel, if it's an Intel branded product, you can be absolutely assured that we follow every single spec by the T. We do 4 corners testing, meaning that our stuff is designed, you know, to be running in the Sahara Desert with like no cooling, you know, or no AC. I mean, everything we design is for the absolute worst case scenario. That includes our fans, you know, the ball bearings, the life expectancy, the machining on the copper, all that kind of stuff. So you will pay a premium with Intel, right? Because Intel is about the highest quality you're going to find for anything that has to do with high tech. but it's something to consider. I've just from being in the business and working in servers for a long time, I can tell you if I was making the purchase and I needed to buy a heatsink solution, I would buy the Intel solution without a doubt. Oh, and one more thing to add about this is from the E5-2600, E5-2600 V2, and now with E5-2600 V3, all our heatsink solutions that have been used for the last 3 years are proven heatsink solutions will continue to work with our new E5-2600 V3. We've designed it so that they can cross right over. It'll handle up to 150 to 160 watts, so you're good to go there. You won't have to do any more research. They're already proven, already been in use for a while. Okay, so I believe this is the last slide I have for you guys. What I'm going to show you here is just a quick difference in the chipset. So a lot of the features are now in the processor, but we still do have a chipset that handles some of the functions. But the great thing about this now is total SATA ports is up to 10, but it's SATA 3, right? If you're going to put in drives, if you want high-performance drives for a server and you're trying to build a low-cost storage solution, we've got 10 SATA 3 6 gigabits per second ports now available with the chipset supporting E5 V3. Clocking, I won't talk about that. That's not important. It just means that it's built into the chipset now. It's what controls the timing on the board. USB ports. If you've ever worked on a server and you have to transfer large files that are associated with servers, you really appreciate USB 3. Now we support up to 6 USB 3 ports on our new E5-2600 V3. And all the systems I've seen so far have that on them, and I really appreciate it when I'm moving operating systems and data around between the machines. PCI Express, not a lot new there, other than that, we just add some additional features here and there. With firmware, several changes. As in before, we support vPro, AMT, etc., but we also support Node Manager 3, DCM or Data Center Manager 4, MCTP, so that's Management Control Transport Protocol. And what that does is that actually allows your management programs, your monitoring programs, to actually look across the PCI bus, so they can have a view into your PCI NIC cards and your SCSI control, or sorry, SATA controllers, etc. Now it's got that technology built in, so the management solutions now will be able to have much more holistic view of the entire system. In addition to that, there's some telemetry and airflow features that are added as well. So I think that's it for me. Yep,
Great.
That's it. Hey, thanks so much. I really appreciate the time to present to you, and now back to Claude.
Yeah, thank you, David. And a lot of information, a lot of good information on our new product. So if you've got questions, again, feel free to ask, and we'll be happy to answer them. And if you think of any afterwards, you'll get our Servers Direct email, so you'll be able to ask them the questions as well, and they carry all these products. So, and I'll let Todd talk about that next. So, Todd, I'll let you take it from here.
Thanks, Claude. Really appreciate it. And David, thank you so much. In the presentation, that was just great stuff. The new Xeon E5-2600 V3 processors are very exciting products. I mean, if anybody who's got servers that are a few years old, the performance benefits they're going to get by upgrading is pretty incredible. So we're already seeing a lot of demand from customers who have been waiting for the new processors, and we are selling them today. So it's just really good stuff. I'm going to spend a few minutes talking about Servers Direct and what we do for our customers, as well as introduce some of our new Xeon E5-2600 V3 servers we're now offering. Then I'll tell you all what you need to do to be entered into the drawing for the Core i3 NUC we're giving away to attendees of today's call to one lucky winner. So before I get started, though, I do have a couple of questions for those of you on the call. And Jody, if you could pull up the questions. The first one is, I'm just curious how many of you are currently customers of Servers Direct? And then the second one, is how many servers are currently deployed in your organization. So it looks like we've got a few people answering. So great. And looks like we've got a pretty wide spread. Looks like we have several customers online. That's good. And then some new people as well. So and then looks like a pretty good spread of different number of servers in each one of your organizations. So so Jody, if you can go ahead and close those out. Thank you very much. Back into the presentation here, go past these slides. So I'd like to tell you a little bit about our company. Our specialty is custom configurations. Our website currently features more than 100 different server configurations, and we're constantly adding new ones on a regular basis. What we like to think of our typical customer is somebody who is too smart to buy from HP or Dell. And I don't mean to say that in any way discouraging those companies or disparaging those companies. Both HP and Dell make great systems, but they're not the exact servers our customers want. Our customers tend to be very technical and people who really understand what is going on inside of their server. And they want to design their own servers using the hardware they specify, whether it's a specific hard drive, memory configuration, RAID controller, or any of a wide variety of other component options. You design it, we'll build it at a good price, and we'll ship it quickly. Those are the things that we strive to do every day. Service Direct has been in business since 2003, and we are currently headquartered in City of Industry, California. We are an ESOP, which means that our employees are extremely dedicated to our customers' happiness. Everybody throughout the company is a part owner of the company, and if our customers aren't happy, then that personally affects them. And so we want to make sure from everybody in the company that take good care of our customers, make sure that they're satisfied throughout every step of the process. We currently have more than 100 technology experts on staff, and our configuration center is a state-of-the-art build facility with ISO and UL certifications and more than 100,000 square feet of manufacturing space. We are currently one of the largest manufacturers of custom hardware solutions in the United States. Now, in case you're not sure exactly what you want, or if you're seeking a server or solution in a brand new category, then one of our expert server consultants is on hand and waiting to help you. We're constantly hearing from customers how much they like their rep, how much they appreciate the fact that they can get somebody on the phone quickly, or they get their emails responded to promptly, or they're able to get online and chat with our reps, and they can really help you collaborate with you to create the exact kind of server that you want. Now, every now and then, we get questions from our customers that we haven't heard before, and that's when we get to leverage our relationship with our vendors. We are a direct OEM for both Intel and Microsoft. We're an authorized integrator with Supermicro, and we have strong OEM relationships with many companies like Seagate, LSI, Asus, Micron, SanDisk, NVIDIA, and many, many other companies. This gives us access to the best build instructions, device optimization strategies, and custom imaging capabilities from some of the smartest server technicians on the planet. So that's a little bit about Servers Direct. Now let me tell you a little bit about the 3 new servers that we're now offering based on the Xeon E5-2600 V3 processors that David just explained to us. First one I'm going to talk about is our part number SDR-2P8D-001. It's a 1U rack mount server. It features dual Intel Xeon E5-2600 V3 processors, up to 512 gigabyte DDR4 2133 megahertz ECC registered memory. This one has 8 2.5-inch SAS and SATA drive bays. Our server product manager was just telling me yesterday that with this series of servers, we're starting to finally see customers really demand the 2.5-inch enterprise drives, which in our customer base, you know, the 3.5 inches is probably stayed around longer than some of the other server manufacturers. But this generation of servers, we are seeing the switch to the smaller drives, and of course, then you can get more drives in a smaller capacity, a smaller form factor, so you can have all the more drives that you need. This one also comes with dual gigabit Ethernet NICs on board, And then you have the option between 563-watt fixed power supplies or the 400-watt redundant power supplies. The next server we're talking about is our part number SDR-2P12V-001. It is a 2U rack mount server, and what makes this one unique is it's ready to go with 12 gigabyte per second drive infrastructure support, which is very popular today, and especially with this new platform, it really gives you the higher throughput on the drives, and along with the new CPUs makes your performance gains just absolutely incredible. This one has up to 1 terabyte of DDR4 2133 megahertz ECC registered memory support. This one goes back to the 3.5-inch hard drives with 12 bays for either SAS3 or SATA 3 drives. And another unique thing about this particular server that we haven't really offered before is it has 10 gigabit. It has an option for 10 gigabit Ethernet NICs on the motherboard itself. So you can get a choice with either 2 or 4 1 gigabit Ethernet NICs or 10 gigabit Ethernet NICs on the motherboard itself. And then this one has the choice of 920-watt redundant power supplies. The third server that we've just released is a pedestal server for you. It actually has a rack mount conversion kit if you do want to turn it into a rack. It's dual CPU support again, the dual Intel Xeon E5-2600 V3s. Also has up to 1 terabyte of DDR4 memory support, 8 3.5-inch hotspot drive bays. It also has the choice of the gigabit or 10 gigabit Ethernet NIC ports on the motherboard, either 2 or 4, and also has 920-watt redundant power supplies. So those are the 3 servers that we've introduced so far. Those are all based on Supermicro. We will have a new server, new E5-2600 V3 server coming out in the next week or so based on a platform for ASUS. And then in October, we're going to introduce several new servers based on Intel server building blocks as well. So stay tuned to Service Direct website, and you will see a variety of new servers coming out to support these incredible new processors. One thing, if you are a new customer for Service Direct, we do have a promotion in place right now. If you buy a server that's at least $2,000, you are eligible to receive either a free SSD drive, an enclosure, or up to a 5% discount up to $250. So for new customers, that should be a good way to introduce yourself to our company, and just contact the salesperson if you're interested in taking advantage of that promotion. And that pretty much wraps up my part of the presentation. We are giving away an Intel Core i3 NUC to one lucky participant of this call. What I need you to do to be entered into that drawing is to go to this survey link. It's surveymonkey.com. You got to get the /S in there, and then the / and then the code TJWQ57L. If you could go there, there's only a few questions on there, just some information on how I can contact you if you've won, and a couple just questions about your operations. And at the end of this webinar, you will be automatically linked to that survey as well if it's too much of a hassle to cut and paste that code into your browser. I will leave that survey open until 5 o'clock Central Standard Time today, and so anybody who's filled out the survey form between now and then will have an entry into that drawing. If you're interested in any of the servers that we just mentioned, that we introduced here in the past couple of weeks, please visit servicedirect.com and then do /E5V3, and that will give you a direct link to those 3 servers. If you have any questions, any quote opportunities, anything that our salespeople can do for you, email them at sales@servicedirect.com. Otherwise, my name is Todd Swank. I'm the Senior Director of Product Marketing. If you have any questions about Service Direct, any questions about the servers we've talked about today, really any questions at all that I can help you out with, please don't hesitate to drop me an email. I'd be happy to help you with whatever I can. So great. I believe that's all I have, Claude.
Great,
so,
Todd. Thank you. And thank you all for attending our event today. I also want to thank David and Todd for presenting, and Kevin and Jeff for answering all the questions as well, and Jody for hosting it. So we look forward to seeing you again on this call, and thank you for your time today. That concludes the audio portion of our webinar, and we'll continue to answer questions online. Thank you.